Today we're gonna do a webinar, talk about a new product we're launching. So it's called a DJI FlightHub 2 all-in-one AIO. So okay, it's at 1, let's get started. So before we talk about the FlightHub 2 all-in-one, we have launched FlightHub 2 back a while ago. And recently we have pushed out a new release for FlightHub 2 users this September, which we have added large language model and AI into FlightHub 2 for media searching and live recognition utilizing LLM. Pretty cool functionality. If you haven't tested that out, highly recommend you to try it out. When we talk about the FlightHub 2, it's been a while, and we have currently covered 85 countries and regions worldwide, and over 2 million missions have been completed under FlightHub 2, and over 400,000 hours of operations have been completed under the FlightHub 2 platform. So today we're making a lot more functionality updates for the FlightHub 2 software. It is a lot different compared to when we released the FlightHub 2 at the beginning. We have added a lot more functionality on the mission planning side, and we have added or integrated AI into the FlightHub 2, whether to support custom recognition model for edge computing, or we embedded the large language model directly inside FlightHub 2 for users to do missions and search based on their defined prompt. And there's more. We have added a lot more features for dock operations specifically, and we're continuously optimizing it. And because it's on a web platform, you can easily access the dock assets or drone operations just to get the first-hand information directly from any web browsers, whether you're using your cell phones, whether you're using your tablets or iPad. You can access directly by logging into FlightHub 2 platform and gather the live footage and current status of your drone operation. So for enterprise customers, they love using the FlightHub 2, but there's also some pinpoints listed out. So they may have a data security concern because of FlightHub 2 is currently hosted on AWS server that is located in the United States. Well, some corporations may want to have the data stored locally, so it's a centralized asset they can take control over instead of having a service on cloud. Second, they may have system integration requirements that requires the drone platform for customizations. So having a non-cloud solution may set a limitation on system integration end. And thirdly, with the data cost, it could be a headache, especially if you have a lot of devices that is under DJI FlightHub 2 platform, and you may not have enough quota for live streaming. So the cloud solution in this scenario might be a little limited for large-scale operations or large-scale fleet. So to solve these pain points, we have released DJI FlightHub 2 on-premises version back in June this year. It is essentially the FlightHub 2, that same FlightHub 2 that is extremely easy to use for a client, but it's on-prem. So that means you can deploy the on-prem services under a local server or under your own private cloud. So today's webinar, we're gonna first talk about on-premises deployment, just kind of do a little review on what the on-premises solution is. And then we're gonna talk about the secondary development capability with the on-premises FlightHub 2. And then we're gonna talk about a new product we're launching today. It's called the FlightHub 2 all-in-one server. So let's talk about on-premises first. What is FlightHub 2 on-premises? So it is a service or software as a service software that can be used and deployed under your local server or local cloud. Whether you're using a private cloud or public cloud or a physical server to host the service, you can have FlightHub 2 deployed under all kinds of scenarios. And user experience is identical to the FlightHub 2. So there's no learning curve switching from FlightHub 2 to on-premises version. Your pilot would have little to no notice when they switch to on-premises version. And because everything is fully localized, the management portion, operation, and maintenance portion is strictly localized also. That means you can ensure the data coming in from the drone stored locally under the server you set up. And because of the system is running under local network, you don't actually need to connect on-premises environment to public internet at all, making it local data mode version for dock operation. If you have experience with local data mode with our non-docked drone operations, basically it's airplane mode, no data coming in, no data coming out. So here are the main features for the on-premises development, on-premises version of the FlightHub 2. Feature-wise, user interface-wise, again, very similar, nearly identical to FlightHub 2. And it's extremely flexible and easy to be deployed. So we provide installation package along with a very detailed deployment guide for users to follow. And all they need to do if they would like to set up the on-premises version of FlightHub 2 is to get the server environment set up. And once they have that environment set up and dependency installed, the installation and deployment is very straightforward, and we provide guide step by step for users. It is, however, a Linux-based software, meaning you have to get an environment set up for a specific version of Linux, that is Ubuntu 22 version. And for deploying the on-premises version, you will need to know the command line interface to have the command typed in within the prompt. Within the terminal to execute commands for installation. But we're not limiting the secondary development for developers. So if developers is currently designing a solution or workflow or custom workflow for the online version of the FlightHub 2, they can take advantage of the FlightHub 2 on premises as well, because we're using the same API calls for on premises. That means the developers combined with the on premises can design custom solution that is also happen to be offline for users. Let's talk about some core differences between the public version and the on-premises version. first of all, the public version provides everything ready to go. You don't actually have to set up anything. It is a software as a service, like I said. But for on-premises, you do need to do some configuration, pre-configuration to get everything up and running. For example, you need to get the offline map imported because we don't actually call map service from public internet. It's on-premises solution, so everything needs to be fully functional under offline condition. So you need to import the building, import the map layer, import the elevation layer for operation reference. And when it comes to the device management, the weather status, message subscription are not available currently for on-premises version because these are all the information that we need to acquire from public internet. The intelligent change detection with on-premises is currently not available compared to the public version. And the large language model for the public cloud version is available for on-premises, but that requires the user to deploy the large language model offline or under the same network environment. So there are many different options, again, to deploy the on-premises. You can deploy under physical server, put it in the server room with AC running stably, or you can put it on the cloud, right? Whether it's private cloud or public cloud like AWS from Amazon or Azure from Microsoft. Having the FlightHub 2 on-prem, you're not missing the functionality for doing reconstruction. DJI FlightHub 2 on-premises also supports the reconstruction for 2D real-time or 2D also mosaic map or 3D mesh or point cloud models. And the experience is just like the FlightHub 2 public version. Basically, under the FlightHub 2 on-premises media library, you just select start mapping, upper left corner, and define the media you like to reconstruct. FlightHub 2 on-premises would utilize the local hardware, local GPU to process these models out for you. When it comes to the data processing, there are going to be some differences between the FlightHub 2 and Terra software. And this FlightHub 2, I'm referring to the public version and on-premises version. And the difference is here. So FlightHub 2 does process with the 2D reconstruction and 3D reconstruction side, but it currently doesn't support the LiDAR point cloud data process and multispectral data reconstruction process. So the data you collected from L-series drone, for example, or multispectral cameras cannot be processed under FlightHub 2. You still need to use DJI Terra software to process those. In advance, we have some deliverables like contour lines, digital elevation models are not currently supported under FlightHub 2. We do not support cluster reconstruction for FlightHub 2 either. So these are the differences here. We do support localized 4G enhanced transmission capability with the FlightHub 2 on-premises environment. However, this is a regional-based support. So if you are living in a region that 4G dongle cannot be used for the service, then this would not work. For example, like United States. But for regions do work with the 4G dongle, you can set up the 4G enhanced transmission service along with the FlightHub 2 on-premises service under the same server environment and configure APN for the same card inserted to the device, to the dongle, sorry, and get that up and running. So little difference here between the public cloud version and on-premises version of FlightHub 2 when it comes to 4G enhanced transmission setup. We all need to have the 4G dongle as attachment to the drone or dock. We also need a SIM card, but for the on-premises, there's a specific dedicated APN card from local network service provider that needs to be purchased and configured. When it comes to the usage method, the public cloud version is plug and play, and for on-premises version is to deploy a localized service along with the FlightHub 2 on-premises, which we provide guidelines on how to do that under the terminal. The user threshold is a little different. For the public cloud version, it's low. For the on-premises version, it's high. And professional services, because of this professional services, is required. And maximum access device for the public cloud is unlimited. And for the on-premises, it depends on the purchased package. And when it comes to the dock and remote control availability, they're the same. So who may take advantage for using the FlightHub 2 on premises? Public safety agencies, firefighting, search and rescue, energy clients, and others, as long as they value the privacy of the data and they do care about having that data being localized and centralized to a whether it's a physical form or to a private cloud. They like to keep the data centralized that way. For these customers, FlightHub 2 on premises will be a very ideal solution for them, because they can connect their drone products as well as DJI dock products to the on-premises environment, and not sacrificing the functionality DJI brought. When it comes to the deployment, requirements, these are the requirements listed, and generally on the right side there's a deployment steps for users to follow. But overall, on the core component requirement side, we do need to have a user to establish an environment that is running Ubuntu, which is a version of a Linux operating system, to be on the 22.04 long-term support version with the Docker installed. Docker is a containerization tool for having the FlightHub 2 running under. So there's a specific version we also require user to install. Again, all these are provided under our deployment guideline, and we provide step-by-step command lines for users to apply them into the terminal to set up the environment properly. When it comes to the server configuration, we recommend CPUs to be 8-core, memories to be 32 gigabytes, storage and network speed as shown. If a user would like to enable the cloud processing or reconstruction capability, they will also need to have a NVIDIA graphics card in the server for that processing, but it's not mandatory. On the right side, basically that shows the overall workflow there. I'm going to bring up the laser point. Okay, so basically first we have the environment preparations, basically getting the dependency and the operating system installed, then get the installation package transferred to the server, unzipped it, then configure this env file, which is a configuration file for you to define where you're going to install the FlightHub 2 on premises to, and define which IP address you like to use and which port you like to use for the component services. And once you have that, you can start the on-premises service deployment and installation. And after that, import your map data and elevation data. So you now have a map layer and elevation layer to reference from. Then after that, getting the device added to the server, create an organization and project on their on-premises environment, and you're ready to go. So that is a very brief through of the deployment process there. Okay, so we have talked about on-premises development and also talked about what on-premises is. The next step is to talk about the capability on custom development side and integration end. This might be interested for developers. Now, let's talk about this. Basic concept here, software as a service and platform as a service. There are some differences here. So for example, FlightHub 2 public version would be a good example of software as a service. And platform as a service is more like providing a platform for developers to build on top. If they want to build, like, say, specific like custom solution over on a well-built structure or platform, they can do something like that. So one example would be AWS, PaaS, platform as a service. But the FlightHub 2 on premises can also be like that. So FlightHub 2 on premises provides API services, just like the public version of FlightHub 2. You can use the open API we have to call the data. That includes the live stream videos, that includes the drone media capture, photos, videos, as well as the drone status and the system status, using the API to call such data to your own software platform that under the development you like to integrate these data or information to perform something custom. That's something you can totally do with the open API here. That's why we think many developers is gonna like using the FlightHub 2 open API, because theoretically the FlightHub 2 public version we are using that same API tools for getting the puzzles built to form a platform for users. Now, these are the core structures of custom development while utilizing the FlightHub 2 cloud version or on-premises version. First, we have FlightHub Sync that synchronizes the data, and we have open API components, and we have front-end components, algorithm and large models, and single sign-on. So by using these tools or development structures, you can connect your custom platform to the on-premises service. So for users' perspective, they can be using the FlightHub 2 on a daily basis with friendly user interface, but also from the developer perspective, in the backend, you can get the data captured from the drone or the latest status of the system synchronized to your custom platforms for further applications. Let's talk about the modular integration. This is the component, the front-end components we saw earlier from the last slide. Basically, the reason we built these are because we first want to reduce the development requirements on something or on functionality that are basic. By doing this reduce the development need for fulfilling functionality that are very simple and straightforward. Secondly, we want to make sure the user have the similar user experience. They don't have the learning curve while transferring to a different platform. These are the components we have, for example, virtual cockpit, the route editing, flight records, and project and map. As you can see, these are the pretty essential components within the drone/dock operation platform. And it's because whether you're designing a custom system for public safety targeted scenarios or to oil and gas energy focused scenarios, these are going to be the same components you'll be using. So instead of having developers redesigning every single part of how you can fly the drones, how you can make the routes, why don't we just make these components available for the developers for them to implement? So right now I have one video just to kind of show you what that process is like or what that outcome is going to be like. So this is a custom system that is calling the front end components. So on the right side, you see there are components that have very similar user interface compared to FlightHub 2 and very similar user logic behind it. But we're still under third-party platform. When it comes to the Open API, we have introduced Open API earlier this year. So compared to the Cloud API, this Open API is more focusing on the software end instead of the hardware end. The one huge benefit for doing this is developers no longer need to do the implementation when there's a new hardware coming out from DJI. They can simply use the Open API to obtain the information they want on the software end. So we use the standard RESTful protocol, and by using Open API, that reduces the development cost because like you don't need to have developers now call essential data with complex code anymore. And we also provide more options as previously Cloud API is a hardware interface. Now Open API is a software level interface here. Yep, so similarly, the concept I was briefly talking about, Open API is on the software end. You don't need to worry about compatibility on the hardware end, whereas the Cloud API is on the hardware end. You need to consider the compatibility for the new hardware when there's any. So that's reduce the maintenance part when it comes to development. So a systematic, I guess, comparison between the Open API and Cloud API. The fee required for the Open API is there for the professional version, enterprise version, or on-premises version. For the Cloud API, it's free. The deployment difficulty will be low for the Open API and relatively high for the Cloud API. And deployment cycle, this is for developers, is relatively short for Open API compared to Cloud API there. And degree of customizations is extremely high from Cloud API, but for Open API, it is generally there and it continues to be iterated. There are more differences here, and I'm gonna go through Next is the large language model algorithms, or this is the object recognition functionality within our software. So there are two ways for achieving object recognition currently on FlightHub 2 platform. The first method is edge computing. So we have a processor on board of our latest enterprise drone that can do object recognition. And only thing you need to do is to import the model that was previously trained. And the general process will be first, developer acquire the development tool for doing the training. And once the training is completed, get the model sent over to our DJI developer platform for quantification. And once that's finished and validated, developers can now get the model physically downloaded into their remote controller, drone remote controller, and push that to the drone, or they can send it to FlightHub 2 and have FlightHub 2 distribute via online or directly to the dock unit. By doing this, now the drone has the capability to do custom object recognition on the edge, and this process is done fully offline. There's no online needed. Second method is going to be online required. So it works backwards, right? So first you have live video feed or image data captured from the dock or a drone system. Then that live videos or live media stream gets pushed to third-party algorithm servers for recognition. And that recognition results would return back to the live stream as a secondary layer and get that displayed on the FlightHub 2 platform, or have the identified results stored under the FlightHub 2 library once the data is recognized. Once the data is done with the object recognition. So it has its downside. For example, it does require the data needs to be transferred to a third-party algorithm vendors, and there will be a latency there. But when it comes to accuracy and the capability, this will be better compared to the edge recognition part. Edge computing recognition option. Next, I'm going to talk about is the FlightHub Sync. FlightHub Sync as part of the secondary development tool is very popular. We have previously released the beta version of this, and we have seen many developers have been utilizing it. And the FlightHub Sync official version will be used to replace that beta version. And we have three main components from the FlightHub Sync side. So we're syncing the data, which is captured from the drones, whether it's media data or the system status data, that is MQTT protocol data, to third-party system. And we're also syncing the live stream data captured from all the cameras, from drone, from dock, to third-party system. The new FlightHub Sync is very intuitive to use because it has a graphical user interface. Users can just follow developers' guidelines to input these addresses or configurations directly on the platform, on the FlightHub 2 platform. So this requires no coding from clients' end when they want to do implementation. So first of all, one example is live stream forwarding. You can now set up live stream forwarding directly from FlightHub 2 and FlightHub 2 on-prem. We support RTMP protocol, also support RTSP that is upcoming. You can define a specific camera from a specific drone device. You want to live stream forward the thermal cameras, for example, you can define that. And we have a little switch here for you to one click to enable or stop the live footage forwarding there for you. For the media transfer, we support all S3 protocol storage buckets. So that can be AWS S3 bucket, Alibaba Cloud, or self-hosted S3 storage bucket. We're transferring media files, and that is one way to the S3 bucket. We're also doing bidirectional flight route and model transfer, as well as the custom flight zones and annotations drawn on the FlightHub 2 platform. We also can push the flight logs to the S3 bucket also. And within the graphic user interface, users can enable certain file type directly by toggle them on and off. MQTT bridging, this is for synchronizing the real-time device information via MQTT bridge to a third-party system. And under the FlightHub sync options, we have a section to enable MQTT and configure MQTT there. When it comes to these development capability, all the functionalities I have laid out, let's have a look and compare between different versions of FlightHub 2. So we have a standard version, which is free version, and pro version, enterprise version. These three are the public version of the FlightHub 2. And we have on-premises version and the FlightHub 2 AIO, which I'm gonna introduce later. So on-premises version and AIO supports all these development capabilities without any issues. The Pro version and Enterprise version supports OpenAPI, FlightHub Sync, and large language model algorithms. And for the Enterprise version, we support single sign-on. This is just one video to show you what that's going to look like when we put everything together, basically having a third-party systems using the Open API to call the offline or device, dock device, and the dock device is utilizing the edge model to perform edge computing and identify a custom object and synchronize that back to the FlightHub 2 and utilize the FlightHub 2 sync to push the media back to the third-party server. So that was the secondary development and or capability FlightHub 2 on-premises offered. Next section, I'm going to talk about this new product we released, which is the FlightHub 2 all-in-one. So what is all-in-one? Basically, it is a sensor. I'm sorry, not sensor. It is a server that has the FlightHub 2 on-premises pre-installed or pre-configured. So by doing this, we are actually having the size of the all-in-one server is very small. So with the on-premises version of FlightHub 2 pre-installed inside it, there are going to be more degrees of freedom when it comes to the setup and deployment end. It can now directly connect to the Dock 2 or the drone via the remote controller. The server itself has a Wi-Fi capability to broadcast the Wi-Fi for remote controller to connect to under the same network to perform that link between the on-premises system and drone device. And it is extremely easy to set up compared to the on-premises version. We have a graphic user interface designed for configuration. So unlike the on-premises version, which requires the command line interface. So fast modeling, the all-in-one computer equipped with a NVIDIA graphics card inside. So that GPU would, with the DJI Terra privatization engine, will be capable for doing rapid 2D mapping and 3D modeling on site. And because of the data is now transferred directly from the device to the AIO server, there's no additional time for users to download the data or transfer that data to a Reconstruction servers for that to get processed. So that data transfer time has been reduced. So just one example here. In emergency missions, the DJI FlightHub 2 can quickly transform 500 drone captured images into a 3D model in just 5 minutes. Okay. And it is very flexible in terms of deployment scenarios. Now, in addition to the server room deployment and office deployment, which you can put this in your server room or office room, you can also put this on a vehicle as long as it provides power. When you get on the site with this device, you can pair this with a Dock 3 device or drone platform that supports FlightHub 2 on premises to complete the data capture, and that data is stored within the all-in-one server. And the all-in-one server is designed with shock and vibration resistance capability. So doing the transportation, that shouldn't be a problem. When it comes to the network configuration, there are different methods for doing the deployment and setup. So deployment independently allows the drone or the AIO, the all-in-one server, to broadcast the Wi-Fi to have user connect their client device, their laptop, tablet, basically to the same network and access FlightHub 2 on premises, as well as having the remote controller access to the same network for getting the drone data, live stream data transmitted to on-premises all-in-one server. Meanwhile, we can have the all-in-one server connect to the dock units via wired connection. Or we can do it completely wirelessly. So that means we can have the on-premises version of a FlightHub 2 with the AIO set up under a server room, for example, and establish network forwarding rules to have external device connect to the environment via public internet. That is totally doable. Or if you want to do something mixed, you can have the all-in-one server that is connected to the dock units via wireless connections. Also, that's something you can do as well. This is a huge difference between the on-premises version and the all-in-one server. Is that all-in-one server can manage and maintenance using the graphical user interface. So again, no service line, no command line interface skill needed for the all-in-one. This is what it's gonna look like on the right side. Very user-friendly, and you just use your mouse cursor to click things around instead of typing all the commands on the terminal side to execute command or changes. One example here is the overall operation and management settings. For example, the system log, how to get it download, configure the domain name and the service ports, upload the offline map tiles, configure the internet, and update the elevation layer data for the on-premises interface, things like that. You can also do account settings and check the activation status there also. Network management, this is a different tab there for the settings. You can configure the wireless network card to enable the AP mode, which broadcasts the Wi-Fi. Or you can do further settings like domain names and SSH. For storage mode, the all-in-one server came with 6 terabytes in total, so that will be 3 times 2 terabytes SSD card. It supports external storage via NAS or storage servers as well. System restore and update. So when there's a new version of the FlightHub 2 on premises, for example, released by us, we can do system update. And by doing that, you just need to import the compressed system update package and upload that to the on-premises via this graphical user interface, and there it is. And you can perform the system update. Similarly, if you want to do the device restore to the factory settings, you can do that as well on this page. System information here show you the all-in-one machine authorization information, the dongle serial number, as well as the authorization information for 4G privatization deployment, administration settings, administration passwords, and time settings. This is for you to configure the local time for it to match up with the data captured from the drone to reference later. You can also do troubleshoot by enabling the remote operation management. This enables the SSH capability for people to easily remote in for troubleshooting and general maintenance if needed. So when it comes to the maintenance, there's a pluggable hardware dongle that is used for installation and replacement that contains the key for the service. And the server itself does supports external storage for expansion use later on. This is the memory or the data storage used for contains all the photos and images. Here we have the spec for the server shown as here listed. It's about 3 kilogram, power about 330 watts, and it's IP45 rated, and with 64 gigabytes of memory and ICU7 processor 265. That's the CPU and NVIDIA RTX 2080. That is the graphics card it is using. The last part is going to be the difference when it comes to the all-in-one server versus the on-premises version. On the capability side, on-premises theoretically supports up to 200 units, and again, that really is going to depend on the depends on the server configuration or specification, I should say. For the given specification on the all-in-one server, it supports up to 20 units. Now that 20 units means 20 online units. So one dock, for example, that will be considered as one unit. Cloud deployment, the on-premises, obviously, you can set it up under AWS or public or private cloud, but for all-in-one server, since it's physical, it's running offline. But you can configure it to be accessible via public internet. Installation and commissioning, yes for on-premises, no for all-in-one, because it's pre-installed. Maintenance workload is heavy and light for all-in-one server with the given graphical user interface, and it's easier to use from there. And the rest of the development capability side we talked about, and local modeling or processing or reconstruction, that, as well as the 4G localization capability, all two supports these. That will be all for today's webinar, and very exciting product here with the FlightHub 2 system installed. I will take any questions if you have any from now on. Do I need a certification to purchase the FlightHub 2 all-in-one solution? No, you don't need a certification to purchase the all-in-one server. Would this allows us to possibly connect our own models to FlightHub 2? So you can import your reconstructed models as long as it's in the correct coordinate systems. Otherwise, it will not show up properly. That coordinate system will be WGS 84 and elevation being ellipsoid height. So yes, you can import your own model into FlightHub 2 as well as the FlightHub 2 all-in-one. Will this material be made public? Yes, we will be sharing the webinar record later. Pricing, we don't have the pricing yet, but keep eyes on our website. We'll release these soon. Well, the Manifold 3 and all-in-one work together. That is a great question. So I don't see why not it wouldn't work together. Okay, that looks like all the questions we got. And thank you all for your time. And if you have any questions or problems, please feel free to reach out to your local dealers. And if not, if you have more questions on the product side support, you can contact support@dji.com. Thank you all.